Welcome to lesson 14. Today we're going to expand a bit more of what we were talking about in the previous lesson with lesson 12 of special types of functions. So in lesson 12 we talked about piecewise functions, which are a special type of function, and now we're going to talk about absolute value functions. So our learning objective today is when given an absolute value functions in words or using function notation, I can make sense of it and create a table of values and a graph to represent it. So we're really pulling it all together using things that we've been doing over the past couple of weeks. And so the first activity introduces what does it mean to have an absolute value function, right? Temperature in Toronto which is a city that borders the United States and Canada. Here are 12 guesses of the average temperature in degrees Celsius in February 2017. The actual average temperature in Toronto in February is 0 degrees Celsius. And so you're going to use this information to sketch a scatter plot, which is just a plot of numbers representing the guesses and the corresponding absolute guessing error. And I'll explain what that means in a second. An absolute guessing error is how far away the guess is from the actual number, right? It's the distance. So if the actual number of the object is 100 and you guess 75, then the absolute guessing error is 25. You're missing 25 from the actual number. And so let's take a look at 5, right? So my first value here of 5 is, I know that my actual value is 0 degrees Celsius. And so my guess in this case, right, is 5 off, right? I'm 5 degrees off. And so my x value is let me label these for you so you can see them a little more clearly, right? My x value is my guess, right? My guess here in this case is 5, and my y is my absolute guessing error, right? How far it is away from the actual number itself. And so at x equals 5, I am 5 away, right, from my value of 0. And the same thing I can see for -5 too. When I have -5, when x equals -5, I'm still 5 away, 5 degrees away, in this case in the negative direction, of my solution, right? So I'm still 5 degrees away. Right, in this case, in the negative direction, because 0 is my goal. And so try to see what the other values will look like and take a look at what the shape of the graph is going to come out as a result. So from that, you're going to create a function a. It gives a distance of x from 0 on the number line. And I want you to complete the table and sketch the graph on the following slide. Andre and Eleanor are trying to find a rule for the function using function notation. And so Andre writes a piecewise function, a equals x when x is greater than or equal to 0, and a equals -x when x is less than 0. And Eleanor writes this rule where we have these 2 bars here. And that's what I wanted to talk about for a second. And so those 2 bars, right, represent an absolute value function. And an absolute value function is a function that takes the input value, right? We take our input value, and the output is the distance from the origin, right? The distance from 0. The origin is 0, right? Our origin is 0. 0, 0 if we want to be more specific. Right, so our input value tells us how far away we are from the origin. So I know that x equaling 8 is 8 spots away from the origin. I know that when we have a -1/2, I also know that even though it's negative, it's still only 1/2 away from my point of 0. And if you need to draw out if you need to draw out a number line, right, here's 0, here's 8. This is 8 spaces away, right? That would be my absolute value. And if I have -1/2, oops, sorry, negative 1/2. This is just 1/2 spaces away. So it's still a positive distance, because remember, distance always is measured in a positive value. You're looking at the distance between that value on the number line and its distance away from 0. So once you start substituting those values in, you'll start to see it come all together in your graph. And so try to sketch out your graph as a result and see what the shape looks like. And so do that definitely before you go on to the next slide. And so in the next slide, we're going to explore a little more of what absolute values look like when you shift them, right? If we always had the absolute value when we're talking about 0 as our distance, but what happens if I wanted to find the distance from 1, or the distance from 2, or the distance from 3? And so see what's happening when I shift this, right? And make sure you answer, what do you notice? I notice blah, blah, blah. And see what happens when you shifted this slider. What is happening to your graph? And so make sure you answer those questions in the graph slide here. And then you will go a little bit further to moving those graphs around and starting to see the connections with their algebraic value. One hint to all of you, if you're feeling stuck, you can try to use the slide before. What happens when my value equals positive 6? Right, what does my graph look like, and where do I see that here? Or when x equals negative, when this value equals negative 6, where does that look like? So if you're struggling here, go back one slide and that should help you. And so last but not least, the lesson summary goes over some more details of what absolute value functions are, so use that if you need any assistance. I will see you in lesson 15.